2.2, we're going to work with something that I know you're familiar with, but we're just going to make sure we've got it down. We're going to be working with some scientific notation. Before we do that, a quick review from yesterday, or from the last section, from section 7.1, where we dealt with both negative exponents and an exponent of 0. So I took two more difficult ones, and we're going to do them, but first I want to talk about what you shouldn't do. So before I start them, I'd like to talk about on this first one right here, when you're simplifying this, how you shouldn't read it. You should not read it as two negatives making a positive, because remember what I told you, we need to do the rules of order. The rules of order say you've got to do your exponent first before we deal with this negative out front. You might want to think of it as either the opposite of all of this to the 0 power, or negative 1 times all of that to the 0 power. But either way, when I do this whole chunk that's in parentheses right here to the 0 power, anything, as long as it's all in parentheses, to the 0 power is 1. But when I have that negative out front, my answer becomes negative 1. Now, again, be very careful with that, because if I put negative 4x, y, z times negative 2 times pi times 7/11, and I raise it out of the 0, anything to the 0 power is 1. But the minute I go like this, and it's outside of the parentheses, that means take the opposite of that, or negative 1 times that, and I get a negative. So be very careful with how you interpret that. On the next one, what I'd like to do is deal with each piece separately. What I mean by that is I've got numbers, m's, n's, p's, and q's. So what I'm going to do first is I'm just going to deal with this 2, and it's 2 to the first, so I'm going to leave it there. Positive exponents stay on their level. Then I have m to the second, also a positive exponent, stays on its level. Then I have n to the negative third, that's going to drop it down, it's 1 over n cubed. P to the 0 is just a 1. Now I'm going to go to the bottom, and I've got an 8, and that's 8 to the first when you don't see it. Again, when I say how old are you, it's 15 or 14 or whatever your age is. Technically, that's to the first power, so we don't say it and we don't write it, but we need to think it. That's 8 to a positive power, so it's going to stay put. Q to the negative fifth is going to go up as q to the fifth. And lastly, on the bottom here, I have a negative 2, and it's in parentheses, squared, which means a negative 2 times itself twice. And a negative times a negative is a positive. Now, my goal is to simplify this, which means I need to get it as simple as possible. And I've got a little bit more cleanup I can do with the numerical part, because ignoring all of the variables, I've got a 2 on the top that can be divided out of the bottom. And I can divide it out of the 4 or the 8, but not 4 and the 8. So I'm going to divide out a 2. 2/8 has always been a fourth, and it still is. So what I've got here is my m squared on the top. Multiplying by 1 doesn't do anything. I've got my q to the fifth on the top. Notice how systematic I'm being about this. I'm dealing with these each individually. Now when I'm done, I'm simplifying it and make sure I've got everything done that I need to have done. On the bottom, I've got a 4 times another 4, which gives me a 16. And then I have an n cubed. So this is my final answer. All right, so next up we're going to do is we're going to deal with, we're not going to do that intro right there because I don't have my calculator out. We're going to talk about scientific notation. Scientific notation formally looks like this. It's some number times 10 to a power. Now we're going to be a little bit more specific here, because this number right here has to be between 1 and 10, but it can't be 10. So technically you would write it like this. It's greater than or equal to 1, but less than 10. So it could be 9.9997, but it can't get to 10. So it's between 1 and 10, but it can't be 10. And this exponent right here has to be what we call an integer. An integer is 0, 1, 2, 3, forever and ever. And it's negatives. Notice there are no decimals, there are no fractions in our scientific notation in the exponent. So let's go discuss these. It says these are not in scientific notation, and you're going to tell me why. What part of this form is it not meeting? and it's this very lead coefficient right here is not bigger than 1. So we would say 0.98 is not between 1 and 10. And we'll discuss about how we move that into scientific notation in just a bit. The next one, what's wrong with this? Is this a number between 1 and 10? It is. Do I have multiplication? I do. Is it by 10? You betcha. However, this is not an integer. So we'd say that exponent, that 1/2, is not an integer. Or you could even say it can't be a fraction if you prefer that. The next one's got lots of things wrong with it. Yeah, I see a 10, but that's a 10 as an exponent. I don't see a multiplication by 10. So let's write no multiply by 10. Alright? So we've got to make sure that when it asks for stuff in scientific notation, we really do put it in formal scientific notation. Now on this chart is something you should be familiar with from your previous math classes, but we're just going to work on it. Standard form is how you would normally see a number, 3,402,000. When we're putting that in scientific notation, we go right to the decimal point, which when you don't see it is at the end. What did I just say? When you don't see a decimal point, it's at the end of the number. Again, with your age, you are 14. Technically, if I had to put a decimal point, I'd put it right there. If I had to put numbers after the decimal point, I'd follow it with zeros. So it's at the end. What I then do is I put it in my proper notation. I'm going to move this decimal. Technically, what I'm doing is I'm dividing by 10 to move it. And I have done that how many times? 1, 2, 3, 4, 5, 6 times to get a number between 1 and 10. And I have to write it until I've got all zeros following it. Repeat that. You have to write, you can't just write 3.4 because that 2 in there matters. So I write 3.402 times 10 to the. How many places did I move it? 6. Now what some kids have a hard time doing is deciding if the exponent should be a positive or a negative. And the best way to think about that is if it's a very large number, like 3 million obviously is, I'd certainly like to have that amount of money, I would be doing a multiplication by 10 to make this a very large number, so a positive exponent. If it's a really small number like this one, very, very, very tiny, very close to 0, then I use a negative exponent. So let's again go right to our decimal point. We're going to keep on moving it until we get a number between 1 and 10. So we've got 4.5 times 10. To what power? Well, how many places did I move it? 1, 2, 3, 4, 5, 6 again. Well, however, notice, right now I've got a problem, and you should see what it is. You should be going, yeah, oh, she should have put a negative 6, because that's a very small number. Remember, I want these to be equal. On this one, because this is a positive 6, I would multiply by 10 6 times. So I move the decimal 1, 2, 3, 4, 5, 6, landing me right back at that number. Same here. This means division by 10 6 times. So I divide by 10, etc., leading me right back to that number. So consequently, that leads us to our next task here. Let's get out of scientific notation. This means multiply by 10 6 times, which is going to move that decimal point to the right 6 places. So I go 1, 2, and then I'm going to need 4 zeros to complete it. All right, now make sure you put your commas in at the correct spots to make it easier for me to read it. So what does this mean? It means division, because that negative exponent by 10 times. So I'm going to move to the left 10 times. Once will get me here. I'm going to need 9 more. So I'm going to need 9 zeros in front of that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, I purposely made a mistake on this also. Notice I didn't put a decimal point anywhere, and you need one. So make sure you put it in here where it's supposed to go. Where does it end up after you move it 9 times? Way over here. All right, then we're not going to create our own. So down on the bottom, really important, that lead number coefficient must be bigger than 1. So let's say between 1 and 10, but it can't be 10. Write this number next up in scientific notation. Well, notice I've got a problem here because that's not between 1 and 10, so it's technically not in correct scientific notation. So what am I going to do? I'm going to tweak it. That's the beauty of math. You can kind of do what you want as long as you don't break any of the math laws. Well, in order for me to get that to be a number between 1 and 10, I have to move that decimal point back 1. So technically what I've just done is divided it by 10. So if I want it to be equal, I've got to multiply by 10 on this side, which means I'm going to bump that exponent up. Now, notice what I've got here. I've kind of got an action and a counteraction. If I move the decimal point back, the exponent goes forward. Likewise, on this next one, to get a number between 1 and 10, I'm going to move that decimal point forward, so I have to move the exponent back. So I get 2.4 times 10 to the 6th. Now again, that might seem kind of weird to you, but let's talk about it just outside of scientific notation. Suppose you wanted to take the number 6 and you want to divide it by 3, but then you don't want to have changed it at all, so then you multiply it by 3. And notice what you end up with. You're right back at that same number. So if you're going to choose to divide and you want to counteract that, you better multiply. Well, in the world of exponents, what that means is, with this base of 10, is that if you're going to divide by 10, let's go like this, to move this back, suppose it, okay, I'm going to write it nice. I'm going to repeat what I've got going here. If I'm going to, say, multiply by 10 to move this forward, then to keep the number in balance, I'm going to have to divide by 10, which will move the exponent backwards. So I'd have 2.41 times 10 to the 5th. You've got to kind of have a counteraction there, and I like if you do the arrows, it helps you to see, well, if this goes forward, the exponent goes back. If the decimal goes backwards, the exponent goes forward. The only problem with that tends to come with if we have negative exponents, and we'll discuss one of those if I don't have one on this page. At the top here, yeah, we'll have one at the bottom, so that'll help. So right here at the top, I'm not going to go through these too much. I'm just going to go real quick. When you're supposed to put these in the proper order, we don't look at the lead number. We look at the power, because that tells us everything about the size of it. I'm having a hard time seeing them, but both of these two are 10 to the 8ths, which totally override 10 to the 7ths. And this one right here is bigger. So this is my biggest one, the Pacific. This is my next biggest. And between these two, obviously 1.41 is smaller than 7.49. Again, I'm going kind of fast because this locks me out at 15 minutes, so I want to get going. I'm going to go to the bottom one down here. When we're multiplying and we're writing answers in scientific notation, I'm going to go like this. If I were to ask you to do 4 times 2 times 3, how would you do that? Most kids would say, well, 4 times 3 is 12. I'm going to double that for 24. Notice, though, what you could do also is you could just remove those parentheses since it's all multiplication, and you could just do 2 times 4 is 8, times 3 is 24. I've got the same thing. The parentheses are really just serving as grouping symbols, and we can do it at multiplication in any order we want. Notice what I can't do, though. I can't say it's 2 times 4, which is 8, and then 2 times 3, which is 6, and then multiply them. That would not be right. That would give me a 48. So what I suggest you do with the scientific notation is just remove those parentheses, because this is all multiplication. That's parentheses mean multiply, this is multiply, so it really doesn't matter what order I do it in. And then I'm going to do these two first. And 3 times 5.4 is 16.2. But we have to write our answer in proper scientific notation. So again, you're going to go back 1. Basically, I'm dividing by 10. So you must go forward 1 or multiply by 10 to balance that out. Same with this next one over here. If I can get it in on time, I'm going to multiply these as if the parentheses are not there. I'm going to get 19.6 times 10 to the negative 5. Not in scientific notation. So you're going to go back 1 to get between 1 and 10, and you're going to go forward 1. Now be careful. What happens when you move negative 5 forward 1? You don't get to negative 6, you get to negative 4. So be careful with those. And that's the end of section 7.2. You have a great day.